The 1.4 notes focus on how technology has helped to advance progress in marine science. We're first going to take a look at what are called submersibles and self-contained diving. The advantage of having such submersibles and self-contained diving is that it allows scientists for the first time to have direct observation and to handle delicate samples. It used to be that the only thing that we saw from the deep ocean was whatever we dredged up or caught in a net by chance. No longer is that the case, because now we can take submersibles to the deep ocean and actually directly observe the sea floor and see what's going on in that natural habitat. Here are some examples of submersibles used to make such observations. The first one ever invented was called the bathysphere. It was a very simple, strong steel sphere that recirculated oxygen. The problem with this is that it had to have an umbilical to the surface. So if you look at this picture, you can see there's a long hose that would connect the sphere to the surface. So this limited this vehicle's ability to maneuver in the ocean. It basically could go up and down, could not go sideways. Well, to improve on that, along came what's called the bathyscaphe, which is also a deep sea submersible. It is a sphere attached to a large float, almost kind of like a blimp. This has no umbilical to the surface. In other words, there's no hose that connected it to the surface. This allowed the vehicle to move horizontally. It is also the deepest diving of all the submersibles that we have designed. In fact, the one pictured here is called the Trieste, and this one actually made it all the way down to the Challenger Deep, the deepest part of the ocean. The modern day submersible that we currently use is known as a deep diving submersible. It's less fragile than the others and much more maneuverable. It is equipped with robotic arms that can collect delicate samples during scientific expeditions. However, it cannot go as deep because it does have an acrylic sphere rather than a steel or titanium sphere. So this can't go as deep as, say, the bathyscaphe, such as the Trieste, which went all the way down to the bottom of the Mariana Trench. Now we're going to talk about self-contained diving. Self-contained diving is basically an individual going down into the water in something that allows them to study, say, a reef or something like that for a longer period of time. The first self-contained diving unit was a hard hat diving apparatus. And then you can see that pictured here. It was basically a hard metal bowl that went over the diver's head, and air was supplied into that helmet using a hose. It was very heavy, and of course it's tied to the surface. There's this very large, cumbersome hose that would have to go up to a boat. To improve upon this, a type of scuba, which is a self-contained underwater breathing apparatus, was developed. One of the first ones developed was what you see pictured here, Flus's scuba. This recirculated pure oxygen in a tank, but it cannot be used deeper than 10 meters as a result of the pressure. To improve on that, Jacques Cousteau developed another type of scuba that uses compressed air rather than recirculating oxygen. This allowed for deeper and longer dives, and it's still the type of scuba apparatus used by marine scientists today. One thing that makes it attractive to even ordinary recreational divers is that it's lightweight and very easy to use. Now we're going to shift our focus from submersibles and diving to special robots and other navigation and satellites that also help us to make observations in the ocean. The first one we're going to talk about is what's called an ROV. That's an acronym that stands for Remote Operated Vehicle. It is a small unmanned sub with a video camera that allows to record observations. It has an umbilical to the surface, so it is somewhat limited in what it can do. But these things have helped us in tremendous ways. An ROV was used to find the Titanic wreck in the Atlantic. Another type of robot used is an AUV, which stands for Autonomous Underwater Vehicle. This is an untethered robotic device that can follow a pre-programmed path. So it does not have to be remotely operated by a person. It can just have a pathway programmed, and it'll follow that and record data as it goes throughout its program. Focusing on to navigation. It used to be that sailors would use the stars to navigate the ocean, but no longer. There's a few forms of electronic navigation used today. One type is long-range navigation, also known as LORAN. It's based on radio signal transmitters that are found along the coast. This, as long as you can pick up 2 of these radio signals, you can determine your position. And it has accuracy to within a few meters. However, its limitation, ironically, is that it's poor at long-range navigation. It's not accurate when you are very far from shore. LORAN is actually being phased out and being replaced by the Global Positioning System, also commonly known as GPS. This is based on a system of orbiting satellites, and it works everywhere on the planet. So that's why it improves upon LORAN in that it's accurate to within 1 to 2 meters and can work anywhere in the ocean. Satellites also help to provide long-term continuous data about the ocean. So in the picture that I just pulled up on the screen here, this is data collected from a satellite that shows wave height. And I believe the way this the color scheme works is that the dark green is very small waves, and light green and yellows are very large waves. You'll notice the Southern Ocean around Antarctica gives us very, very large waves in comparison to what we have up here in the Atlantic Ocean. And we'll talk about the significance of that when we study wave propagation in the physical geography unit. But again, the point here is that satellites allow us to collect a large amount of continuous data from the ocean, something we've never been able to do. The data you see here would probably take decades of sailing to collect, but this was collected by a satellite in a period of about 1 day. So there's many other versions of technology or types of technology that help with scientific observation in the ocean. And we'll be talking about them and revisiting some of the ones we talked about here as we go through this course in marine science. But I felt it was important that we touch on some of the basics just to kind of be familiar with how scientific observation has improved as a result of technology.